Hello everyone, today we will read the chapter number 12 from the book Fundamentals of Physical Geography, NCERT textbook for class 11, chapter 12, World Climate and Climate Change. So let's get started. The world climate can be studied by organizing information and data on climate and synthesizing them in smaller units for easy understanding, description and analysis. Three broad approaches have been adopted for classifying climate. They are empirical, genetic and applied. Empirical classification is based on observed data, particularly on temperature and precipitation. Genetic classification attempts to organize climates according to their causes. Applied classification is for specific purpose. Next point is Koeppen's scheme of classification of climate. The most widely used classification of climate is the empirical climate classification scheme developed by Koeppen. Koeppen identified a close relationship between the distribution of vegetation and climate. He selected certain values of temperature and precipitation and related them to the distribution of vegetation and used these values for classifying the climates. It is an empirical classification based on mean annual and mean monthly temperature and precipitation data. He introduced the use of capital and small letters to designate climatic groups and types. Although developed in 1918 and modified over a period of time, Koeppen's scheme is still popular in use. Koeppen recognized 5 major climatic groups. 4 of them are based on temperature and 1 on precipitation. Table 12.1 lists the climatic groups and their characteristics according to Koeppen. The capital letters A, C, D and E delineate humid climates and B dry climates. The climatic groups are subdivided into types designated by small letters based on seasonality of precipitation and temperature characteristics. The season of dryness are indicated by small letters F, M, W and S, whether F corresponds to no dry season. Next table is climatic groups according to Koeppen. A or tropical climate. Characteristics of tropical climate is average temperature of the coldest month is 18 degree or higher. Next is B or dry climate. Characteristics of B climate is potential evaporation exceeds precipitation. Group C, warm temperate. Characteristics: the average temperature of the coldest month of the mid-latitude climates years is higher than -3 degrees Celsius but below 18 degrees Celsius. Group D, cold snow forest climates. The average temperature of the coldest month is -3 degree or below. E or cold climates, average temperature of all month is below 10 degrees Celsius. H or highland, cold due to elevation. Next is M or monsoon climate. W, winter dry season and S means summer dry season. The small letters A, B, C, D refers to the degree of severity of temperature. The B dry climates are subdivided using the capital letter S for steppe or semi-arid and W for desert. The climatic types are listed in table 12.2. The distribution of climate groups and types is shown in table 12.1. Next is tropical Group A, tropical humid climate. Type, tropical wet or AF, no dry season. Next is tropical monsoon or AM, monsoonal short dry season. Next, tropical wet and dry, AW, winter dry season. Next group is B or dry climate. First is subtropical steppe, BSH, low latitude semi-arid or dry. Next, subtropical desert, BWH, low latitude arid and dry. Mid latitude steppe, BSK, mid latitude semi-arid or dry. Mid latitude desert, BWK, mid latitude arid or dry. Next group is C, warm temperate or mid latitude climates. Humid subtropical, CFA, no dry season, warm summer. Mediterranean, CS, dry hot summer. Marine west coast, CFB, no dry season, warm and cool summer. Group D, cold snow forests climate. Humid continental, DF, no dry season, severe winter. And subarctic, DW, winter dry and very severe. Group E or cold climate, tundra, ET, no true summer. And polar ice cap, EF, perennial ice. H for highland, type highland, highland with snow cover. First is tropical humid climate or A, group A. Tropical humid climates exist between Tropic of Cancer and Tropic of Capricorn. The sun being overhead throughout the year and the presence of intertropical convergence zones make the climate hot and humid. Annual range of temperature is very low and annual rainfall is high. The tropical group is divided into three types, namely AF or tropical wet climate, AM tropical monsoon climate, AW tropical wet and dry climate. Next is tropical wet climate or AF. Tropical wet climate is found near the equator. The major areas are the Amazon basin in South America, western equatorial Africa and the island of East Indies. Significant amount of rainfall occurs in every month of the year as thunder showers in the afternoon. The temperature is uniformly high and the annual range of temperature is negligible. The maximum temperature on any day is around 30 degrees Celsius while the minimum temperature is around 20 degrees Celsius. Tropical evergreen forest with dense canopy cover and large biodiversity are found in this climate. Next is tropical monsoon climate or AM. Tropical monsoon climate is found over the Indian subcontinent, northeastern part of South America and northeastern Australia. Heavy rainfall occurs mostly in summer. Winter is dry. The detailed climatic account of this climatic type is given in the book on India Physical Environment. Next, tropical wet and dry climate, AW. Tropical wet and dry climate occurs north and south of AF type climate regions. It borders with dry climate on the western part of the continent and CF or CW on the eastern part. Extensive AW climate is found to the north and south of Amazon forest in Brazil and adjoining parts of Bolivia and Paraguay in South America, Sudan and south of Central Africa. The annual rainfall in this climate is considerably less. are considerably less than the AF and AM climate types, and is variable also. The wet season is shorter and the dry season is longer, with drought being more severe. Temperature is high throughout the year and diurnal range of temperature are greatest in the dry season. Deciduous forest and tree-shaded grasslands occur in this climate. Next point is dry climates B. Dry climates are characterized by very low rainfall that is not adequate for the growth of plants. These climates cover a very large area of the planet, extending over large latitudes from 15 degree to 60 degree north and south of equator. At low latitudes from 15 to 30, they occur in the area of subtropical high, where subsidence and inversion of temperature do not produce rainfall. On the western margin of the continents adjoining the cold currents, particularly over the west coast of South America, they extend more equatorwards and occur on the coastland. In middle latitudes from 35 degree to 60 degree north and south of equator, they are confined to the interior of the continent, where maritime humid winds do not reach, and the two areas often surrounded by mountains. Dry climates are divided into steppe or semi-arid climate or BS and desert climate or BW. They are further subdivided as subtropical steppe or BSH and subtropical desert BWH at latitudes from 15 degree to 35 degree, and mid-latitude steppe BSK and mid-latitude desert BWK at latitude between 35 to 60 degree. Next point is subtropical steppe or BSH and subtropical desert BWH climate. Subtropical steppe or BSH and subtropical desert or BWH have common precipitation and temperature characteristics. Located in the transition zone between humid and dry climates, subtropical steppe receives slightly more rainfall than the desert, adequate enough for the growth of sparse grasslands. The rainfall in both the climate is highly variable. The variability in the rainfall affects the life in the steppe much more than the desert, more often causing famine. Rain occurs in short, intense thunder showers in deserts and is ineffective in building soil moisture. Fog is common in coastal deserts bordering cold currents. Maximum temperature in the summer is very high. The highest shaded temperature of 58 degrees Celsius was recorded at Al-Ajijia, Libya on 13th September 1922. The annual and diurnal range of temperature also high. Next is warm temperate or mid-latitude climates or sea climates. Warm temperature or mid-latitude climates extend from 30 degree to 50 degree of latitude, mainly on the eastern and western margins of the continents. These climates generally have warm summers with mild winters. They are grouped into four types: humid subtropical, that is dry in winter and hot in summer, CWA, or Mediterranean, CS, and humid subtropical, no dry seasons and mild winter, CFA, and Marine West Coast climate, CFB. Humid subtropical climate, CWA. Humid subtropical climate occurs poleward of Tropic of Cancer and Capricorn, mainly in North Indian plains and South China interior plains. The climate is similar to AW climate except that the temperature in winter is warm. Next is Mediterranean or CS. As the name suggests, Mediterranean climate occurs around the Mediterranean Sea along the west coast of continents in the subtropical latitudes between 30° to 40° latitudes, that is Central California, Central Chile, along the coast in the southeastern and southwestern Australia. These areas come under the influence of subtropical high in summer and westerly wind in winter. Hence, the climate is characterized by hot, dry summer and mild, rainy winter. Monthly average temperature in summer is around monthly average temperature in summer is around 25 degrees Celsius and in winter below 10 degrees Celsius. The annual precipitation rate is 35 to 90 centimeter. Next, humid subtropical climate or CFA climate. Humid subtropical climate lies on the eastern part of continent in the subtropical latitudes. In this region, the air masses are generally unstable and cause rainfall throughout the year. They occur in eastern United States of America, southern and eastern China, southern Japan, northeastern Argentina, coastal South Africa and eastern coast of Australia. The annual averages of precipitation vary from 75 to 150 centimeter. Thunderstorms in summer and frontal precipitation in winter are common. Mean monthly temperature in the summer is around 27 degrees Celsius and in winter it varies from 5 degree to 12 degrees Celsius. The daily range of temperature is small. Next is Marine West Coast or CFB. Marine West Coast climate is located poleward from the Mediterranean climate on the west coast of continents. The main areas are northwestern Europe, west coast of North America, north of California, southern Chile, southeastern Australia and New Zealand. Due to marine influence, the temperature is moderate and in winter it is warmer than for its latitude. The mean temperature in summer month ranges from 15 degree to 20 degrees Celsius and in winter 4 degree to 10 degree Celsius. The annual and daily ranges of temperature are small. Precipitation occurs throughout the year. Precipitation varies greatly from 50 to 250 centimeter. Next is cold snow forest climate. Cold snow or D climate. Cold snow forest climates occur in the large continental area in the northern hemisphere and between 40 degree to 70 degree north latitudes in Europe, Asia and North America. Cold snow forest climates are divided into two types: DF, that is cold climate with humid winter; DW, cold climate with dry winter. The severity of winter is more pronounced in higher latitudes. Next is cold climate with humid winter, DF, and cold climate with humid winter occurs poleward of marine west coast climate and mid latitude steppe. The winters are cold and snowy. The frost free season is short. The annual range of temperature are large. The weather changes are abrupt and short. Poleward, the winters are more severe. Next point is cold climate with dry winter or DW. Cold climate with dry winter occurs mainly over northeastern Asia. The development of a pronounced winter anticyclone and its weakening in summer sets in monsoon-like reversal of wind in this region. Poleward summer temperatures are lower and winter temperatures are extremely low, with many locations experiencing below freezing point temperatures for up to 7 months in a year. Precipitation occurs in summer. The annual precipitation is low, from 12 to 15 centimeter. Next point is polar climate or E climate. Polar climates exist poleward beyond 70-degree latitude. Polar climates consist of two types, tundra or ET and ice cap or EF. Tundra climate or ET. The tundra climate is also called after types of vegetation like low-growing mosses, lichens, and flowering plants. This is the region of permafrost where the subsoil is permanently frozen. The short growing season and waterlogging support only low growing plants. During summer, the tundra region have very long duration of daylight. Next point is ice cap climate or EF climate. The ice cap climate or EF occurs over the interior Greenland and Antarctica. Even in summer, the temperature is below freezing point. This area receives very little precipitation. The snow and ice get accumulated and the mounting pressure causes the deformation of ice sheets and they break. They move as icebergs that float in Arctic and Antarctic waters. Plateau Station, Antarctica, 79° south, portray this climate. Next is highland climate or H. Highland climates are governed by topography. In high mountains, large changes in mean temperature occur over short distances. Precipitation types and intensity also vary spatially across highlands. There is vertical zonation of layering of climatic types with elevation in the mountain environment. Next point is climate change. The earlier chapters on climate summarized our understanding of climates as it prevails now. The type of climate we experience now might be prevailing over the last 10,000 years with minor and occasionally wide fluctuations. The planet Earth has witnessed many variations in climate since the beginning. Geological records show alternation of glacial and interglacial periods. The geomorphological features, especially in high altitude and high latitudes, exhibit stresses of advances and retreats of glaciers. The sediment deposits in glacial lakes also reveal the occurrence of warm and cold periods. The rings in the trees provide clues about wet and dry periods. Historical records describe the vagaries in climate. All these evidences indicate that change in climate is a natural and continuous process. India also witnessed alternate wet and dry periods. Archaeological findings show that the Rajasthan desert experienced wet and cool climate around 8000 BC. The period 3000 to 1700 BC had higher rainfall. From about 2000 to 1700 BC, this region was center of Harappan civilization. Dry conditions accentuated since then. In the geological past, the earth was warm some 500 to 300 million years ago through the Cambrian, Ordovician and Silurian periods. During the Pleistocene epoch, glacial and interglacial periods occurred. The last major peak glacial period was about 18,000 years ago. The present interglacial period started 10,000 years ago. Climate in the recent past. Variability in climate occurs all the time. The 90s decade of last century witnessed extreme weather events. The 1990s recorded the warmest temperature of the century and some of the worst floods around the world. The worst devastating drought in Sahel region south of Sahara Desert from 1967 to 1977 is one such variability. During the 1930s, severe drought occurred in southwestern Great Plains of United States, described as the Dust Bowl. Historical records of crop yield or crop failures, of floods and migration of people tell about the effects of changing climate. A number of times Europe witnessed warm, wet, cold and dry periods. The significant episodes were the warm and dry conditions in the 10th and 11th centuries when the Vikings settled in Greenland. Europe witnessed little ice age from 1550 to 1850. From about 1885 to 1940, world temperature showed an upward trend. After 1940, the rate of increase in temperature slowed down. Causes of climate change. The causes for climate change are many. They can be grouped into astronomical and terrestrial causes. The astronomical causes are the changes in solar output associated with sunspot activities. Sunspots are dark and cooler patches on the sun which increase and decrease in a cyclical manner. According to some meteorologists, when the number of sunspots increase, cooler and wetter weather and greater storms occur. A decrease in the sunspot numbers is associated with warm and drier conditions. Yet these findings are not statistically significant. And another astronomical theory is the Milankovitch oscillations, which infer cycles in the variations in the Earth's orbital characteristics around the Sun, the orbling of the Earth and the change in the Earth's axial tilt. All these alter the amount of insolation received from the Sun, which in turn might have a bearing on the climate. Volcanism is considered as another cause for climate change. Volcanic eruption throws up lots of aerosols in the atmosphere. These aerosols remain in the atmosphere for a considerable period of time, reducing the sun's radiation reaching the Earth's surface. After the recent Pinatubo and Elsion volcanic eruptions, the average temperature of the Earth fell to some extent for some years. The most important anthropogenic effect on the climate is the increasing trend in the concentration of greenhouse gases in the atmosphere, which is likely to cause global warming. Next point is global warming. Due to the presence of greenhouse gases, the atmosphere is behaving like a greenhouse. The atmosphere also transmits the incoming solar radiation but absorbs the vast majority of long wave radiation emitted upward by the Earth's surface. The gases that absorb long wave radiation are called greenhouse gases. The processes that warm the atmosphere are often collectively referred to as greenhouse effect. The term greenhouse is derived from an analogy to the greenhouse used in cold areas for preserving heat. A greenhouse is made up of glass. The glass which is transparent to incoming shortwave solar radiation is opaque to outgoing long wave radiation. The glass therefore allows more radiation and prevents the long wave radiation going outside the glass house, causing the temperature inside the glass house structure warmer than outside. When you enter a car or a bus during summers where windows are closed, you feel more heat than outside. Likewise, during winter, the vehicles with closed door and windows remain warmer than the temperature outside. This is another example of greenhouse effect. Next point is greenhouse gases. The primary greenhouse gases of concern today are carbon dioxide, chlorofluorocarbons, methane, nitrous oxide, and ozone. Some other gases such as nitric oxide or NO and carbon monoxide or CO easily react with greenhouse gases and affect their concentration in the atmosphere. The effectiveness of any given greenhouse gases molecule will depend on the magnitude of the increase in its concentration, its lifetime in the atmosphere, and the wavelength of radiation that it absorbs. The chlorofluorocarbons are highly effective. Ozone, which absorbs ultraviolet radiation in the stratosphere, is very effective in absorbing terrestrial radiation when it is present in the lower troposphere. Another important point to be noted is that the more time greenhouse molecule remains in the atmosphere, the longer it will take for Earth atmosphere system to recover from any change brought about by the latter. The largest concentration of greenhouse gases in the atmosphere is carbon dioxide. The emission of carbon dioxide comes mainly from fossil fuel combustion, that is oil, gas, and coal. Forests and oceans are the sinks for the carbon dioxide. Forests use carbon dioxide in their growth, so deforestation due to change in land use also increases the concentration of carbon dioxide. The time taken for atmospheric carbon dioxide to adjust to changes in sources to sinks is 20 to 50 years. It is rising at about 0.5% annually. Doubling of concentration of carbon dioxide over pre-industrial level is used as an index for estimating the changes in climate in climatic models. Chlorofluorocarbons are products of human activity. Ozone occurs in the stratosphere while the ultraviolet rays convert oxygen into ozone. Thus, ultraviolet rays do not reach the Earth's surface. The CFCs which drift into the stratosphere destroy the ozone. Large depletion of ozone occurs over Antarctica. The depletion of ozone concentration in the stratosphere is called ozone hole. This allows the ultraviolet rays to pass through the troposphere. International efforts have been initiated for reducing the emission of greenhouse gases in the atmosphere. The most important one is the Kyoto Protocol, proclaimed in 1997. This protocol went into effect in 2005, ratified by 141 nations. Kyoto Protocol bounds the 35 industrialized countries to reduce their emissions by the year 2012 to 5% less than the level prevalent in the 1990. The increasing trend in the concentration of greenhouse gases in the atmosphere may in long run warm up the Earth. Once the global warming sets in, it will be difficult to reverse it. The effect of global warming may not be uniform everywhere. Nevertheless, the adverse effect due to global warming will adversely affect the life supporting system. Rise in the sea level due to melting of glaciers and ice caps and the thermal expansion of the sea may inundate large parts of the coastal area and islands, leading to social problems. This is another cause for serious concern for the world community. Efforts have already been initiated to control the emission of greenhouse gases and to arrest the trend towards the global warming. Let us hope the world community responds to this challenge and adopts a lifestyle that leaves behind a livable world for the generations to come. One of the major concerns of the world today is global warming. Let us look at how much the planet has warmed up from temperature records. The annual average near surface temperature of the world is approximately 14 degrees Celsius. An increasing trend in the temperature was discernible in 20th century. The greatest warming of 20th centuries was during two periods, 1901 to 1944 and 1977 to 1999. Over each of these two periods, global temperature rose about 0.4 degrees Celsius. In between, there was a slight cooling, which was more marked in the northern hemisphere. The globally averaged annual mean temperature at the end of 20th century was about 0.6 degrees Celsius above the recorded at the end of 19th century. The 7 warmest years during 1856 to 2000 were recorded in the last decade. The year 1998 was the warmest year, probably not only for 20th century but also for the whole millennium. This is for today. Thanks for listening.